Hello there, and welcome back to the Sleep Science. Tonight you tilt your head up and picture the sky stretched out like a velvet blanket, peppered with more stars than you could ever count before nodding off. Somewhere among those dots, a little smudge of light is creeping, faint and shy at first, the kind of thing you'd miss unless someone told you to look. That smudge has a name, or at least a catalogue tag, and it's called 3I/ATLAS. Doesn't exactly roll off the tongue, but trust me, it's worth staying awake for a few minutes to meet it. This is one of those rare celestial visitors that makes astronomers spill their coffee and rush to their telescopes. They've spotted comets before, sure, but this one is different. It's not from here. It didn't form in the familiar icy outskirts of our solar system, like Pluto's cold cousins. No, this object came sailing in from the vast, nameless dark between the stars. If you've ever had an uninvited guest who somehow became the life of the party, you'll get the vibe. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, drop a comment with where you're listening from and what time it is right now. There's something cozy about knowing someone across the planet is drifting off at the same time you are. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You imagine yourself standing beside astronomers in Hawaii in the spring of 2020, when the ATLAS survey, the Asteroid Terrestrial Impact Last Alert System, which sounds much scarier than it usually is, picked up a new moving point of light. The system is basically a planetary neighbourhood watch, designed to give us early warning about space rocks that might aim for Earth. Most of what it catches are humdrum asteroids minding their own business, but every now and then it surprises us. This time, it noticed something on a trajectory that didn't make sense. The light flickered just enough to betray motion against the background stars. You trace it with your eyes, like trying to follow a speck of dust gliding across a sunbeam. Scientists gave it the temporary name C/2020 M3, before eventually upgrading it to 3I/ATLAS. The I stands for Interstellar, because this wasn't just another icy dirt ball looping around the sun. It had the audacity to come from beyond. Historians still argue whether ancient people saw such interstellar objects before, and simply didn't have the language for them. Imagine being a Babylonian scribe staring at a sky where a new star appeared and vanished within weeks. Was it a comet? A planet? A messenger from the gods? The truth is lost to clay tablets and guesswork. But what we do know, every culture has treated strange lights in the sky as omens, often terrifying ones. A quirky tidbit: comets once carried the delightful nickname hairy stars, because their fuzzy tails looked like celestial bad hair days. I suppose Bad Hair Star 3I/TLAS doesn't inspire much awe, but hey, ancient astronomers did what they could. Back in our present, the Atlas survey team ran the math. The object's incoming speed was way too fast for it to have originated inside the solar system. Objects born here obey the sun's gravitational leash. This one looked more like it had hopped a fence from another cosmic backyard. Normally that would mean it's just passing through, like a tourist snapping a quick picture before heading back home. But here's where the plot thickens. You probably won't survive this revelation, at least not if you were expecting ordinary. Instead of slingshotting straight back out, the calculations hinted that 3I/ATLAS might actually be sticking around. Like someone who came to crash on your couch for a weekend and is still here months later, leaving socks in the dryer. The excitement builds, and you let yourself float into the idea. An alien comet, captured, a permanent guest. In a universe where everything seems to move on, 3I/ATLAS has parked itself in our celestial cul-de-sac. You breathe slower, sinking deeper into the pillow, imagining the faint smudge of light still gliding across that velvet sky. No rush, no drama. Just the quiet thrill of knowing you're sharing the neighbourhood with something that came from impossibly far away. You let your mind drift, still picturing that faint smudge moving across the black canvas above you. But the question lingers: what actually makes astronomers so certain that 3I/ATLAS is interstellar? After all, a comet is a comet, right? An icy ball trailing a little misty tail. Well, not quite. The devil, as they say, is in the orbital details, and the details here are so peculiar that they stand up and wave their hands like someone trying to order a latte in a crowded cafe. You watch the orbit being traced on a glowing computer simulation, the kind of diagram astronomers love to argue over. Most comets in our system follow closed elliptical loops, tidy ovals stretched like rubber bands. They may dive in toward the sun, sizzle a little, and then swing back out to the deep freeze. But 3I/ATLAS doesn't obey those rules. Its trajectory looks hyperbolic, like a sling, wide open on one end, suggesting that it came in from infinity and was supposed to head back out to infinity. It's the cosmic equivalent of a road tripper who never intended to stop for gas. That's the giveaway. Velocity plus shape. Its speed on arrival was too high to have been nudged into motion just by Neptune or Pluto. It had to be born far away, under some other star's glow. The calculations aren't just guesswork. Astronomers run them with the same math Isaac Newton scribbled down centuries ago when he first linked an apple falling with the pull of the moon. Now historians still argue whether Newton really did sit under a tree and take a bonk on the head from a falling apple, or if that's just one of those charming myths we tell students to make physics more palatable. Either way, his laws of motion and gravity are the very same ones that betray the foreign origin of 3I/ATLAS. And here's a fun, slightly bizarre tidbit. Some early astronomers before Newton's time thought comets were atmospheric phenomena, basically clouds of fiery vapour hanging just above the Earth. One philosopher even suggested they were the breath of dragons exhaled into the sky. It wasn't until careful observers tracked their positions night after night that humanity realised comets had to be way out in space, far beyond the moon. But back to Atlas. You follow the numbers scrolling down a screen, and they all sing the same tune, eccentricity. The measure of how stretched an orbit is. An eccentricity of 0 means a perfect circle, 1 means an infinitely long parabola. Atlas comes in at just over 1, hyperbolic, interstellar. Like its earlier cousin, Oumuamua, but with a different personality. You imagine yourself standing on some alien world, a planet circling a sun that isn't our own, watching as a chunk of icy rubble gets knocked loose by a gravitational scuffle. Maybe 2 planets collided and sprayed shards across their system. Maybe a passing star tugged too strongly and flung icy leftovers into the void. One of those shards drifts for millions of years, cold and silent, until it finally crosses our path. That shard is what you're imagining as 3I/ATLAS. And if you're wondering why this matters, because of course part of you is, it's because each interstellar object is like a postcard from another solar system. We can't travel light years to grab samples from distant stars, but sometimes those stars politely deliver souvenirs right to our doorstep. Your breath slows as you picture it. Dust frozen since before Earth even formed, older than the first dinosaur's footprint, older than the oldest human story whispered by firelight. Drifting through the night sky now within reach of our telescopes, carrying secrets in its ice. You smirk at the thought. Humans get excited about meteorites on eBay, polished into jewellery or sitting in display cases. But here's something rarer, a whole visitor from another star system. Astronomers joke that if eBay allowed it, interstellar comet fragments would crash the site with bids. Yet the seriousness isn't lost. The interstellar origin isn't just a cool fact, it changes how we look at the thing. This isn't just a comet in the family tree of Halleys and Hale-Bopp, it's an outsider, an immigrant. And the shocking twist is that, instead of a quick hello goodbye, it might actually be staying for the long haul. You let that sink in as your eyelids grow heavy, the numbers and diagrams fading into something dreamlike. Orbital eccentricities soften into watercolour arcs, and you're left with just the simple truth: Atlas isn't from here. And yet, somehow, it's here now. You're still lying back, feeling the slow rhythm of your breathing, when your mind drifts toward a memory. Not your own, but one carried in the collective stargazer's scrapbook. The year is 2017, and the astronomical world is buzzing with the arrival of the very first confirmed interstellar visitor, a strange, elongated object named 1I/Oumuamua. You picture yourself standing on a quiet mountaintop, peering through a telescope just days after its discovery. Astronomers describe it as oddly shaped, like a cigar tumbling through space. Others compare it to a pancake, depending on which model you prefer. Either way, it's not the usual potato-shaped comet or asteroid. No glowing tail, no comforting familiarity, just a silent shard of something alien, racing away faster than we could catch it. Historians still argue whether Oumuamua was truly natural. Was it just an unusually thin rock? Or could it have been something engineered, perhaps a fragment of alien technology? One thing's certain. Avi Loeb, the Harvard astronomer who will keep showing up in tonight's story, stirred the pot by suggesting we at least consider that possibility. The scientific community, not exactly famous for cozy campfire consensus, split right down the middle, and here's a quirky tidbit to tuck under your pillow. Some newspapers actually ran headlines calling Oumuamua the interstellar space cucumber, not quite as poetic as its Hawaiian name, which means a messenger from afar arriving first. You can imagine an alien civilization cringing at being compared to a salad ingredient. You trace back through your memory and recall how scientists scrambled, desperately trying to get telescopes pointed at Oumuamua before it zipped out of sight. It was moving too fast, already outbound, a drive-by encounter with no time to plan a spacecraft rendezvous. It left us with only grainy data and endless debates. Now roll that feeling forward into the present with 3I/ATLAS. Unlike Oumuamua, this one actually looks more like a comet. It has the faint, misty emissions that scream ice and dust, a much more traditional look for a visitor. Still, the comparison matters because these two interstellar objects now form the beginnings of a new category. The first was weird, the second a little more ordinary, but both are precious, like the first two stamps in a cosmic passport. As you let that sink in, you realize how remarkable it is that humanity has lived for thousands of years under the stars, only to notice interstellar guests just recently. Were they always there, too faint for naked eyes? Or are we just lucky, living at a time when telescopes can actually catch them? You smirk again at the thought of the ancients. Imagine being a medieval villager, looking up at a strange comet and assuming it foretold doom. Now fast forward. Modern astronomers do the same thing, except instead of predicting plague or famine, they predict funding applications and conference debates. The mood hasn't changed all that much, just the language. You follow the thread of thought into sleepier territory, picturing Oumuamua fading into the distance, a streak of curiosity we could never chase. But unlike that elusive first visitor, ATLAS is lingering, holding its place in the sky like a bookmark waiting to be read again and again. And somewhere in the back of your mind you can almost hear Avi Loeb's voice reminding you, if we don't study these things carefully, we're missing out on one of the greatest opportunities in human history. Your eyes grow heavier, the story slipping into something quieter, softer, as though you're travelling alongside these visitors on their endless journeys. You let yourself float further, and now Avi Loeb steps into the picture like a professor who somehow wandered into your dream, carrying chalk in one hand and cosmic curiosity in the other. He's the kind of scientist who doesn't mind poking at sacred cows, even if the herd gets spooked. Harvard astronomer, longtime black hole theorist, and in recent years, the loudest voice insisting that interstellar visitors might hold more than just icy dust. You picture him in a lecture hall calmly pointing to a slide of Oumuamua, then to 3I/ATLAS, and saying in that careful academic way, "We should keep an open mind." And you know how dangerous those words can be in science. They sound gentle, but they're often the spark that ignites entire controversies. Loeb's claim, the one that put him on talk shows and in countless headlines, was that Oumuamua might not be a natural rock at all. Maybe it was a fragment of alien technology, a thin light sail drifting through space. Was that likely? Not really. Was it impossible? Also, not really. Historians still argue whether the backlash to Loeb's idea was about the evidence itself, or just about scientists' discomfort at being asked to take aliens seriously. And here's a quirky tidbit. After publishing his book Extraterrestrial, Loeb started the Galileo project, which aims to build networks of telescopes to scan the skies for unidentified aerial phenomena and interstellar objects. The project's name is a cheeky nod to Galileo Galilei, who famously pointed a telescope skyward in 1609 and made establishment scholars very uncomfortable by suggesting Earth wasn't the centre of everything. Turns out ruffling feathers runs in the family of astronomy. You imagine Loeb at his desk surrounded by stacks of papers, writing late into the night with the kind of stubborn determination that makes other scientists roll their eyes. To him, 3I/ATLAS isn't just another icy wanderer. It's another chance to prove that our neighbourhood in space is constantly open to visitors, and maybe, just maybe, not all of them are geological. It's easy to picture the skeptics too. You hear their voices like a chorus. "It's just a comet, Avi. Nothing unusual. But then the counterpoint arrives. Well, how many comets from outside the solar system have you studied before? Silence follows because the list is exactly 2. Your thoughts meander back to history again, to those scholars in the 19th century who argued about whether meteors really came from space. Some insisted they were just atmospheric flashes, until a shower of stones literally fell in front of a French village in 1803. That event forced a rewrite of textbooks overnight. Who's to say another rewrite isn't waiting with objects like ATLAS? You smile at the irony. Humans, the species that collects stamps, baseball cards and Pokemon, now have a brand new collection to obsess over. Interstellar rocks. Loeb is just the loudest kid in the room shouting, "Don't lose them!" And as you lie there, eyelids heavy, you can almost hear the gentle bickering of scientific conferences, the applause, the skepticism, the sighs. Loeb doesn't mind. His role in this story is clear. He's the one telling you not to look away, not to dismiss Atlas as just another comet. In the dim quiet of your room, that voice lingers, calm but insistent. This isn't just science, it's history, unfolding in real time above your head. You feel your body sink deeper into the mattress, the edges of your thoughts blurring like a long exposure photograph, while the comet's tail takes on a stranger twist. Because unlike its earlier cousins 3I/ATLAS doesn't look like it's in any hurry to leave. That's the shocker, the reason astronomers straightened up in their chairs. Instead of slipping past the sun and vanishing into the void, ATLAS seems to be settling down. You picture the math again, those delicate orbital curves drawn against the black. Normally, interstellar visitors are hit-and-run affairs. They speed through, wave politely at the sun, and then vanish back into interstellar night. Oumuamua did exactly that, leaving nothing but debates in its wake. The second known visitor, 2I/Borisov, discovered in 2019, behaved more traditionally, streaking in with a spectacular tail and then swinging away again, never to be seen. But Atlas? This one is the wallflower who came to the party and decided the snacks were too good to leave. Astronomers ran the orbital simulations again and again, and the math kept whispering the same unlikely phrase, captured. Historians still argue whether comets like this have been captured before. Some suspect that a few of the ordinary comets we track might actually be immigrants who joined the solar system millions of years ago disguised as locals. Others think capture is vanishingly rare, a 1 in a million fluke. There's no consensus, just a tantalizing uncertainty that makes this case all the more delicious. And here's a quirky tidbit to savor. In 1901, a French astronomer named Camille Flammarion suggested that interstellar comets might sometimes settle in our solar system, and that perhaps even Earth itself was seeded by such icy vagabonds. At the time, his colleagues chuckled, the way academics often do when someone leaps a little too far ahead. But sitting here now, you can almost hear Flammarion whispering, "Told you so." You imagine Atlas swinging through its path, feeling the gravity of planets tug at it like strings in a slow-motion dance. Its incoming speed was high, but not quite high enough to escape forever. Combine that with a lucky interaction or two and suddenly the math shifts. Instead of an open-ended hyperbola, you get an elongated ellipse, a bound orbit. That thought sends a shiver of wonder through you, a rock from another star system here to stay. It's like finding out the Airbnb guest isn't leaving on Sunday, but is quietly unpacking in the spare room. And while your eyelids grow heavier, you let yourself play with the idea. Centuries from now, future astronomers may look at 3I/ATLAS and forget that it was ever a visitor. They'll catalogue it alongside other comets, unaware of its passport. And yet, you, drifting here in the 21st century, know the truth. This comet is an outsider turned resident. You breathe slow, steady, picturing the sky above you. Somewhere out there, this faint icy traveller has decided not to leave, and the solar system feels just a little less lonely. The quiet hum in your room deepens as your mind drifts into the patterns of orbits, graceful arcs traced across the black canvas of space, like ribbons floating in slow motion. You let yourself imagine 3I/ATLAS, not as a rock but as a dancer, caught up in a performance choreographed by gravity itself. The sun pulls gently at the comet, Jupiter tugs insistently from the sidelines, and the smaller planets add their little nudges, almost like background percussion. The path is not a neat oval you could doodle in a notebook. No, Atlas loops in wide, skewed sweeps, its trajectory stretched and tilted at angles that make ordinary comets look tidy by comparison. The orbit resembles something more like a cosmic doodle, an elongated ellipse that nearly folds back on itself, a shape that suggests bound, but still feels precarious. Historians still argue whether orbital captures like this last forever, or if they're more like temporary leases. Maybe in a few thousand years, another nudge could knock Atlas loose again, sending it back into the interstellar wilderness. Others think this comet might stay locked for millions of years, patiently circling, an adopted child of the solar system. And here's a quirky tidbit. In the late 1800s, mathematician Henri Poincaré studied orbital mechanics and realized that even the tiniest gravitational tweaks could make a system unpredictable, a finding that later fed into chaos theory. So when you look at Atlas's orbit, with its odd loops and near misses, you're really watching chaos written across the sky, the same kind of math that explains why weather forecasts get dicey after a week. You smirk at the thought, predicting the future of a comet isn't so different from predicting whether you'll actually stick to your gym plan. Both are influenced by tiny nudges you can't fully control. In your mind's eye, you zoom out. The solar system becomes a stage, planets like spotlight operators, their gravity beams shaping the comet's dance. Each time Atlas swoops in near Jupiter, its orbit shifts slightly, sometimes pulled tighter, sometimes stretched longer. One wrong encounter, and it could have zipped free forever. But this time, it seems, the steps aligned. The beauty of it is that you don't have to rush. The comet's ballet plays out over centuries and millennia, slower than the rise and fall of empires. Humans will come and go, technologies will flare and fade, but Atlas will keep moving through its elongated routine, circling under the sun's patient gaze. And as you feel your own breath sinking to the rhythm of that orbit, slow, steady, almost elliptical, you realize how strangely comforting it is. In a universe where everything feels fleeting, this one alien traveler has chosen to linger. The room is quiet, you're breathing steady, when you imagine the great heavyweight of the solar system lumbering into view, Jupiter, the planet with sticky fingers. If the Sun is the boss, Jupiter is the enforcer, the one whose gravitational pull reshapes everything in its vicinity. And in the case of 3I/ATLAS, it's Jupiter's invisible tug that likely turned a brief visit into a long-term stay. You picture the scene in slow motion. Atlas drifts in from the interstellar dark, carrying the faint scent of alien ice. Its trajectory is hyperbolic, open-ended, destined to slide past the Sun and back into emptiness. But then, as it glides near the orbit of Jupiter, the planet's immense gravity grabs it, ever so slightly. A nudge here, a pull there, and suddenly the comet's fate is rewritten. This isn't unusual in principle. Jupiter has been acting as a cosmic goalie for billions of years, deflecting or capturing objects that wander too close. Many of the short-period comets we know, like 67P/Churyumov-Gerasimenko, the one visited by the Rosetta mission, are thought to be Jupiter family comets. They owe their looping orbits to past encounters with the gas giant. Historians still argue whether Jupiter protects Earth or endangers it. Some researchers claim its gravity shields us from catastrophic impacts by sweeping dangerous objects out of the way. Others insist that Jupiter actually throws more asteroids inward, making our planet a target-rich environment. The debate is ongoing, a reminder that even our supposed guardians can be double-edged. And here's a quirky tidbit. Galileo, who first turned his telescope on Jupiter in 1610, was so astonished by its 4 largest moons that he initially called them Medicean stars, hoping to flatter the wealthy Medici family into funding his work. In other words, science has always had a side hustle in marketing. Back to Atlas, you can almost see Jupiter's massive presence, its swirling clouds and thunderous storms, reaching out across millions of kilometers. Its pull is what bends the comet's path just enough to keep it from flying away. It's like a bouncer gently but firmly redirecting someone back into the dance floor. You chuckle at the thought of Jupiter as the ultimate collector of strays. It hoards moons by the dozens, snatches up comets, and even toys with asteroids, some of which trail behind it like crumbs after a cosmic picnic. Atlas may just be its latest acquisition, a new bauble in the gas giant's oversized jewellery box. And as you sink deeper into drowsiness, You let that image settle. An alien comet, tethered not by chains, but by the soft, relentless pull of a planet too massive to ignore. The whole solar system is a web of invisible strings, and Jupiter, as always, has both hands on the loom. Your mind drifts into the slow-motion debates of astronomers, the kind that play out not over minutes but over decades. 3I/ATLAS might be here to stay, but just how rare is that? You picture a room full of scientists at a conference, coffee cups in hand, politely arguing about probabilities while secretly wishing they were outside with the telescopes. One camp insists that the capture of an interstellar comet is vanishingly unlikely. Think about it. Most of these visitors are moving at breakneck speeds, 30 or 40 kilometers per second, like marathon runners who don't have time to tie their shoes. The sun's gravity might bend their paths, but without some extra assist, like a tug from Jupiter, they usually just slingshot away again. The other camp, equally confident, argues the opposite. Given enough time, they say, capture is inevitable. The solar system has been around for billions of years, swimming in a galaxy crowded with stars. Surely thousands, maybe millions, of interstellar objects have brushed past us in all that time. Some of them must have been snagged and now blend in, masquerading as native comets. Historians still argue whether this debate resembles earlier fights over meteorites. In the 1700s, many scientists flatly denied that rocks could fall from the sky, dismissing villagers who swore they'd seen it happen. Only when thousands of stones fell near L'Aigle in France in 1803 did the skeptics finally give in. Maybe the capture argument is in the same stage, waiting for a big, undeniable proof. And here's a quirky tidbit. When Borisov, the second confirmed interstellar comet, was discovered in 2019, one astronomer quipped, "It took us 400 years of telescopes to find one, and then another shows up almost immediately. Maybe they're like buses. So perhaps capture isn't as rare as it feels. It just took technology catching up." You imagine 3I/ATLAS frozen in your mind's eye, looping around the sun, its orbit plotted in faint white chalk against a blackboard sky. Is this a permanent lease, or just a long sublet? The models can't quite agree. One suggests thousands of years of stability, another millions. A third says Jupiter might toss it back into space on some distant future pass. But right now, lying here with your breath softening, the exact timeline doesn't matter. What matters is the quiet thrill of knowing you're alive at the moment when humanity is first grappling with these questions. Captured or not, permanent or temporary, Atlas is rewriting our expectations, and as your eyelids sag heavier, you realize the debate itself is part of the beauty. In science, uncertainty isn't failure, it's the lullaby that rocks us toward discovery. Your breath slows as the bigger picture unfurls, because this isn't just about one icy traveller. It's about what interstellar objects like 3I/ATLAS mean. You picture yourself leaning back in a creaky observatory chair, staring at the data on screen and realizing, these aren't just rocks, they're care packages from the cosmos. Every comet holds clues to its birthplace. The chemical mix, the ratios of isotopes, the dusty minerals, they're like accents in a cosmic language, telling you whether the object grew up near a young hot star or in a quiet icy nursery at the edge of a system. If Atlas really is settling down here, then it's a library card to a collection we never thought we'd get to borrow from. Historians still argue whether our solar system alone could explain Earth's ingredients, water, organics, and the building blocks of life, or whether outside contributions were essential. Maybe the soup of life needed a few alien spices tossed in, delivered by interstellar comets like ATLAS. And here's a quirky tidbit. In the 1980s, scientists discovered amino acids, basic building blocks of proteins, in meteorites that fell to Earth. One of them, the Murchison meteorite in Australia, carried more than 70 kinds of amino acids, some not found in any earthly biochemistry. Imagine opening your pantry and finding spices no cookbook even mentions. You picture Atlas tumbling silently, its frozen heart packed with chemical treasures, forged around a star you'll never see with the naked eye. It's a cosmic time capsule, older than human history, perhaps older than Earth itself. And beyond the scientific intrigue, there's something almost poetic about it. Here we are, fragile beings who fret about taxes and laundry, while alien matter drifts casually into our backyard, offering hints about the origin of everything we know. You chuckle softly in the dark, Astronomers debate whether to classify ATLAS as interesting science or profound philosophical event. Maybe it's both, because when you strip it down, every interstellar rock is proof that we're not isolated. Our solar system is open to visitors, whether they're brief tourists or permanent residents. As your eyelids grow heavy, you let that comfort wrap around you. We're part of a bigger story, and sometimes the universe literally delivers the evidence straight into our orbit. Your mind drifts toward the quiet but thrilling possibility that makes scientists sit a little straighter in their swivel chairs. Could objects like 3I/ATLAS carry the seeds of life itself? You picture the comet, not just as frozen rubble, but as a capsule with the potential to scatter organics wherever it goes, sprinkling the galaxy like a gardener with infinite patience. This idea has a name, panspermia. The notion that life, or at least the ingredients of life, can hitch rides on comets, asteroids, or even dust grains travelling between stars. Some versions are humble, suggesting only that comets spread amino acids and sugars. Others are bold, hinting that entire microbial hitchhikers might survive deep freeze and radiation to awaken when they find a welcoming world. Historians still argue whether panspermia is plausible science or just poetic speculation. Some researchers see it as unnecessary. Life, they argue, could easily have started right here on Earth. Others point to discoveries like amino acids in meteorites or simple sugars on comets and ask, why not both? And here's a quirky tidbit to tuck into your dreams. In 2014, the Rosetta spacecraft's lander, Philae, detected the smell of Comet 67P. If you could sniff it, scientists said, you'd notice hints of rotten eggs, bitter almonds and horse stables. Not exactly Chanel number 5, but unmistakably organic. If ordinary comets carry such chemistry, what might an interstellar one like Atlas be hiding? You imagine Avi Loeb pacing in his office, reminding his colleagues, if we don't investigate, we'll never know. To him, ATLAS isn't just a curiosity, it's a possible courier of alien biology. He doesn't claim it's definitely alive, only that ignoring the chance is short-sighted. You picture Atlas thawing slightly as it swings near the sun, releasing gas and dust, tiny particles drifting outward like seeds on the wind. Most settle harmlessly into space, but a few, just maybe, could fall inward, brushing against Earth's atmosphere or even landing on our soil. You chuckle softly, thinking about how ancient myths warned of comets bringing plagues. Turns out the ancients weren't completely wrong. Comets really could deliver something microscopic. The difference is that modern science sees that not as a curse, but as a gift, a hint of connection to a larger galactic family. Your eyelids grow heavier as the thought expands. If life's building blocks are scattered everywhere, then maybe life itself isn't rare. Maybe the galaxy is a garden, and comets are simply the gardeners, endlessly sowing seeds across the stars. The quiet deepens as your mind drifts backward in time, long before telescopes and orbital mechanics, to an age when comets were not scientific curiosities, but omens painted across the sky. You imagine yourself as a farmer in ancient China, looking up at a glowing streak and wondering what heavenly message it carries. The chronicles say comets foretold dynastic changes, floods, or even the deaths of emperors. Cross the world to Rome, and you see Julius Caesar's funeral in 44 BCE. A brilliant comet blazed for 7 nights, and the people took it as proof of Caesar's deification. Historians still argue whether the comet was Halley's or some other visitor, but the symbolism stuck. It was the Julian star, and coins soon carried its image. And here's a quirky tidbit. Medieval Europeans sometimes feared comets so intensely that they prescribed remedies for comet sickness. One such cure involved drinking a potion of powdered emerald dissolved in wine, which if nothing else at least sounds glamorous compared to modern cough syrup. You picture how little those ancient watchers understood of what they were seeing. To them, comets seemed to appear out of nowhere, blazing unpredictably, then fading into nothing. Without knowledge of orbits, they couldn't know these were repeat visitors, icy messengers returning faithfully every few decades or centuries. Fast forward to the Renaissance, when Tycho Brahe, the Danish astronomer with the golden nose prosthetic, carefully tracked a comet in 1577. His precise measurements proved it had to be farther away than the moon, shattering the old Aristotelian idea that comets were atmospheric vapours. It was a small but crucial step toward the modern understanding you now take for granted. comets are ancient, icy relics, not celestial smoke. Lying here, you realise there's something comforting about this historical continuity. People across millennia looked up, gasped, and whispered about comets, whether in fear, reverence, or curiosity. And now, with 3I/ATLAS, you're part of that same tradition, except instead of powdered emeralds, we have orbital simulations and conference papers. Your eyelids grow heavier as the thought softens. Comets have always been storytellers, whether their tale is doom, divinity, or data. And Atlas, the newest narrator, is whispering its story into the stillness of your night. Your thoughts drift back to 3I/ATLAS itself, shimmering faintly against the black backdrop, and you begin to imagine its subtle tale. Not the dramatic painterly plume of Halley's comet, but a ghostly whisper of dust and gas barely there, like the trail of a candle just blown out. Comets are unpredictable this way. Some roar to life near the sun, others sputter with barely a glow. Astronomers peered at Atlas, expecting fireworks, but instead found only faint emissions. Still, even that wisp reveals a lot. The ice is evaporating, the dust loosening, the comet slowly bearing its core. And comets have a long history of surprising scientists when they do this. Historians still argue whether comet Shoemaker-Levy 9's breakup in 1992, before its spectacular crash into Jupiter 2 years later, could have been predicted. Some said its strange string of pearls formation was unprecedented. Others insisted they'd seen hints in earlier comets. Either way, the event turned the quiet mystery of comets into front-page drama. And here's a quirky tidbit. In 2001, astronomers watched comet 289P/Blancpain disintegrate into nearly nothing. Yet, a tiny remnant survived, still orbiting today like a ghost of itself. Comets, it seems, are masters of the disappearing act. You imagine Atlas as another trickster. Maybe it will brighten unexpectedly on its next pass, shedding layers like a cosmic onion. Or maybe it will fragment, splitting into smaller pieces, leaving future astronomers scratching their heads. After all, the comet's very name, Atlas, comes from the survey telescope that found it, but it also evokes the mythic Titan who carried the heavens. There's a poetic irony in a comet named for strength being so fragile. And beyond the tail lies the core, a dirty snowball, crusted with dust, perhaps riddled with cracks. No spacecraft has yet flown close enough to sniff it directly, but you can imagine its texture, dark, crumbly, colder than anything you've ever touched. You smirk at the memory of the European Space Agency's Rosetta mission, which revealed Comet 67P's surface to look like rubber ducks fused together. If Atlas someday reveals a shape equally ridiculous, it will fit right into the comet family tradition of cosmic oddities. As your eyelids sink lower, the comet's faint glow softens in your imagination. Its tail, thin as breath, stretches gently behind, a reminder that even the quietest celestial wanderers carry secrets worth unravelling. The air in your room feels slower now, as though time itself has thinned out, matching the pace of the comet's long, frozen journey. You imagine 3I/ATLAS drifting silently through the void, a fragile vault of ice and dust carrying secrets from another star system. Comets like this are sometimes called cosmic time capsules, and the phrase feels fitting. Sealed containers of history older than anything carved into stone, older than the Earth's oceans, older even than the sun's glow. The comet's icy heart preserves the chemical fingerprint of its birthplace. Whatever gases, dust, and molecules surrounded its original star millions or billions of years ago are still locked inside, chilled to near absolute zero. If you could scoop a piece into your hands, you'd be holding a story from a time and place humanity will never visit directly. Historians still argue whether life on Earth required exactly this kind of delivery, whether comets and asteroids provided the essential water and carbon compounds, or if our planet brewed them up alone in its early volcanic cauldrons. Every new comet studied tilts the balance of that debate a little, but never closes it. And here's a quirky tidbit. When scientists drilled into Antarctica's ice, they found microscopic grains older than the solar system itself, interstellar dust that had floated down like snow. In a sense, we've already held whispers of other stars in our hands, but Atlas offers something bigger, a whole intact relic instead of scattered crumbs. You picture yourself floating alongside Atlas, brushing a hand across its jagged surface, feeling the silence of millennia radiating from it. Each crack in its crust is a scar from some ancient encounter, each buried layer a frozen diary entry from a star system you'll never see. Your breathing slows further, almost syncing with the comet's imagined orbit, long and deliberate. There's something soothing about the thought. While civilizations rise and fall, while entire languages are born and vanish, Atlas keeps circling, patient and unchanged, like a reminder that time is vaster than we ever let ourselves feel. Now the words grow softer, stretching like shadows at dusk. The comet drifts on, carrying its quiet cargo, waiting for the future, whether that means scientists probing its chemistry, or simply the endless lull of circling the sun. You allow yourself to melt into that imagery. A dark sky, one comet glowing faintly, a library of secrets drifting just overhead, far beyond worry or hurry. The stars keep watch, the silence grows heavier, and you, like the comet, find yourself gently settling into orbit, safe and still. Your breath is calm now, steady as the comet's long loop, and your mind drifts forward, wondering what the future might bring when sharper eyes are turned toward 3I/ATLAS. Telescopes today are powerful, yes, but compared to what's on the horizon, they're like magnifying glasses held up to a keyhole. You imagine the Vera C. Rubin Observatory in Chile set to begin full operations soon. Its enormous camera, the size of a small car, will survey the entire sky every few nights. With it, faint objects like Atlas will be tracked with precision. Their brightness shifts caught in detail. Every twitch of light could reveal dust clouds, rotation, or hidden jets of gas. And farther out on the timeline, you picture space telescopes even more advanced than James Webb. Instruments capable of splitting a comet's faint light into spectral rainbows, teasing apart the fingerprints of carbon, nitrogen, and maybe even exotic compounds that never formed in our solar system at all. Historians still argue whether the golden age of astronomy was the 17th century, when telescopes first revealed craters on the moon, or whether it's happening now, with digital detectors and space-based observatories. The truth might be that every century has its golden age, and a TLAS will be lucky enough to be studied in this one. And here's a quirky tidbit. The Rubin Observatory's digital camera has 3.2 billion pixels, which means a single exposure would take up more storage than 1,500 Netflix movies. Imagine trying to stream a comet in 4K. Atlas would crash your Wi-Fi before you could blink. You picture future astronomers programming observation schedules, pointing massive arrays of mirrors toward ATLAS. Each dataset they gather is another brushstroke on the portrait of this alien guest. Perhaps its composition will prove familiar, echoing the icy worlds of our own Oort cloud. Or perhaps it will reveal strange chemistry, something that tells us, unmistakably, this comet grew up under another sun. As you drift deeper, you can almost hear the quiet click of shutters opening in observatories scattered across Earth, all aimed at the same faint smudge of light. While you lie here in the softness of night, an invisible army of lenses is already keeping watch, turning starlight into knowledge. Your eyelids weigh heavier, the thought growing faint and gentle. The comet will be there, waiting, circling, for future telescopes to reveal what your eyes never could. Your thoughts drift forward again, past the watchful gaze of telescopes and into the restless imagination of engineers. Staring at that faint interstellar smudge on their monitors, some can't help but wonder, what if we went there? What if we didn't just watch 3I/ATLAS circle quietly, but actually reached out with a spacecraft to shake its icy hand? You picture a meeting room filled with mission proposals, sketches on whiteboards, engineers waving their arms to describe trajectories like dancers plotting arcs in the air. Could we send a probe to chase Atlas, to sniff its gases, to scoop up dust grains and read the comet's history firsthand? The excitement hums beneath the technical jargon, because this isn't just another space rock, it's a piece of another solar system. Historians still argue whether the greatest missed opportunity of modern astronomy was our failure to send a mission after Oumuamua. When it arrived in 2017, it was already speeding out of reach before we could even finish arguing about what it was. Some scientists still groan about the what-if of that lost chance, like stargazers who watched the biggest firework burst just as their camera batteries died. And here's a quirky tidbit. A group of researchers has already sketched a mission concept called Project Lyra. Their wild idea, launch a fast probe that could still, even years later, catch up with Oumuamua on its outbound path. It's a long shot, requiring exotic propulsion tricks and decades of travel, but it shows how determined some people are not to miss the next one. You imagine the same spirit being applied to ATLAS. Unlike its predecessors, it's staying, looping through the solar system again and again. That buys us time. Maybe the next generation of spacecraft could rendezvous with it, land gently on its surface, drill into its crust, and return samples, tiny vials of another star's leftovers, waiting to be opened in earthly labs. Your mind drifts further, picturing astronauts of the far future standing on Atlas itself, their boots crunching through alien frost, their helmets reflecting a sun that is familiar, and yet a world beneath them that is utterly foreign. Your breathing steadies, syncing with the patient rhythm of those imagined missions. Whether in your lifetime or not, humanity will eventually reach out, unwilling to let a cosmic gift linger unexamined. And Atlas, patient as ever, will be waiting in its slow orbit, a silent rendezvous partner. You let yourself sink deeper into the thought of those future missions, and slowly another idea creeps in. The worry that not everything about welcoming an alien visitor is safe. Because while the dreamers imagine collecting alien chemistry, the warriors imagine alien contamination. Picture this: a probe scoops dust from 3/ATLAS and returns it to Earth. Scientists open the sample canister in a pristine lab, and then, what if those grains carry something unexpected? Maybe just unusual organics, maybe something reactive, or maybe even microbes hardy enough to survive eons in space. It sounds like science fiction, but it's exactly the sort of scenario planetary protection guidelines obsess over. Historians still argue whether fears of cosmic contamination are exaggerated or essential. Some point out that Earth has been bombarded with meteorites for billions of years without any alien plagues emerging. Others counter that controlled exposure in a lab is different from random dust burning up harmlessly in the atmosphere. Both sides quietly admit, we don't actually know. And here's a quirky tidbit. During the Apollo program, NASA quarantined returning astronauts along with their lunar rocks, just in case the moon harbored unknown microbes. The poor astronauts spent weeks in sealed trailers, staring at their souvenirs through thick glass, before officials finally decided the moon was barren. You smirk at the thought of future scientists being locked in quarantine with a piece of ATLAS, passing the time by playing cards while technicians run bioscans outside. Sorry folks, just making sure you didn't bring back alien mold. But on the flip side of risk lies reward. Even if Atlas holds nothing alive, its frozen chemistry could teach us volumes about planetary formation around other stars. Its ices might contain ratios of hydrogen and deuterium that hint at how water formed in its original system. Its dust could carry minerals unknown to our solar system entirely. The reward, if you weigh it, is staggering. You drift deeper, imagining Earth scientists of the future huddled around microscopes, gas chromatographs and spectrometers, their screens glowing with alien data. Some shake their heads in disbelief, others smile in awe. Humanity has always lived on second-hand stories about distant stars. Yet here, finally, are physical samples delivered across light years. Your eyelids sink lower, the debate softening into a lullaby. Risk or reward, fear or wonder, both threads are woven into the same fabric of curiosity. And just as the comet balances between capture and escape, so too does our imagination balance between caution and hope. Your mind drifts back to Avi Loeb, the professor whose voice has become a kind of chorus throughout this night. If most astronomers speak in careful whispers, Loeb is the one who dares to shout across the room, insisting we not miss what might be the most important moment in human history. You picture him leaning forward at a conference table, eyebrows raised, saying, "If we ignore interstellar objects, we are ignoring a messenger." And he doesn't just mean scientific messenger, he means possibly technological, possibly intentional. He's the one reminding everyone that history rewards the curious, not the complacent. His predictions are bold, sometimes outrageous to his critics. He argues that the galaxy may be littered with artifacts, fragments of alien technology, space junk from civilizations long gone, or perhaps deliberate beacons. Most scientists hedge, retreating into probabilities and caveats. Loeb charges forward, daring to say the word aliens out loud where others mumble it. Historians still argue whether such boldness helps or hurts. Some say Galileo's willingness to confront dogma is exactly what science needs. Others mutter that extraordinary claims require extraordinary evidence, and that Loeb is undermining credibility by leaping too far ahead. But then again, history has often sided with the stubborn outlier. And here's a quirky tidbit. In interviews, Loeb likes to compare the scientific community to kids refusing to look through Galileo's telescope because they're afraid of what they might see. It's a little dramatic, sure, but he clearly enjoys the metaphor, casting himself as the annoying but persistent kid tugging your sleeve, saying, "Just look." You smirk at the thought. If astronomers were at a party, Loeb would be the one turning off the music mid-song and announcing, "There might be aliens in the backyard. Don't you think we should check?" Half the room rolls their eyes, the other half runs to the window. But whether you agree with him or not, his role in this story is undeniable. He keeps the conversation alive, keeps the tension sharp. Without voices like his, perhaps interstellar objects would pass unremarked, filed away as footnotes instead of front-page mysteries. As your eyelids droop, you hear his message soften in your mind. Don't be afraid to wonder. Don't be afraid to take visitors seriously. It echoes like a lullaby from the stars themselves, urging you toward curiosity, even in dreams. You let yourself drift now into the ripple effect. The way 3I/ATLAS isn't just a line on an astronomer's chart, but a spark that lights up the public imagination. Because every time one of these interstellar visitors shows up, people who haven't thought about comets in years suddenly step outside at night, craning their necks, wondering if they can catch a glimpse. You picture news anchors fumbling through the pronunciation 3I Atlas, or is it I3 Atlas, while glossy animations show a glowing rock swooping dramatically past Earth. Newspapers call it alien debris. Podcasts debate whether it's proof of life, and social media fills with photos of blurry night skies where someone swears they caught it on their iPhone. Historians still argue whether this kind of public fascination is fleeting or enduring. Halley's comet, for instance, drew global attention in 1910, with some people buying comet pills to ward off supposed poisonous gases, while others threw comet-themed parties. Then, decades later, Halley returned in 1986, but pollution and faint brightness left many underwhelmed. The hype fizzled. Will Atlas be remembered as headline candy, or as the start of a new era of discovery? And here's a quirky tidbit. In the 1700s, French entrepreneurs sold comet insurance to people terrified that a comet would crash into Earth. Pay a small premium, and if the world ended, well, technically the company wouldn't have to pay out anyway. An early example of cosmic capitalism at its finest. But fascination isn't just fear anymore. In forums and comment threads, you read posts from amateur astronomers, stargazers, even kids sketching comets in their school notebooks. Atlas isn't only a data point, it's a story, a reminder that the universe is alive with visitors, and we're not the only star system sending rocks out into the dark. You smirk at the thought. Humans have a way of turning everything into pop culture. If Atlas lingers, it wouldn't be surprising to see its name slapped on craft beers, indie bands, or maybe a sci-fi series. Season 2 of Atlas drops next fall, but beneath the memes and headlines there's something steadier. Every time people talk about comets, they're really talking about curiosity, about looking up instead of down. And as you breathe slowly, your eyelids heavier than before, you sense the quiet magic in that. Atlas may be faint in the sky, but its real brightness is in the way it makes us remember to wonder. The night feels hushed now, and your thoughts turn from news clippings and telescope feeds to something softer, something closer to philosophy. Because beyond the numbers and the arguments, there's the deeper question: what does it mean when a piece of another star system decides to stay here, among us? You imagine the solar system as a house, its planets arranged like furniture, its asteroids like clutter in the attic. For billions of years, the door has been open, even if we didn't notice. 3I/ATLAS walked in, shrugged, and decided not to leave. And suddenly the house feels less private, less solitary. Historians still argue whether humans have ever truly shaken the belief that we are central, special, set apart. First Earth was the centre of the cosmos, then the sun, then the galaxy. Each demotion stung. Maybe comets like Atlas are the next step in that humbling ladder, not proof of alien civilizations, but reminders that we live in an interconnected galaxy, where fragments of faraway systems sometimes drop by unannounced. And here's a quirky tidbit. The Stoic philosopher Seneca, writing nearly 2,000 years ago, speculated that comets followed orderly paths, not random appearances. He admitted he might not live to see proof, but trusted future generations would. It was a patient kind of faith, that the universe was bigger and more connected than people realized. You lie there, eyes half closed, and feel that same patient faith settling in your chest. Maybe Atlas doesn't carry microbes or alien artifacts. Maybe it's just ice and rock. But even so, it's a piece of elsewhere that now belongs to here. And in that simple fact, there's comfort. The galaxy is not empty. Stars trade matter the way people trade stories, scattering fragments of themselves across the void. One of those fragments is circling with you now, sharing the same sun, the same stage of space. Your breathing softens, your thoughts stretch out like shadows at twilight. You and Atlas, both drifting under the same cosmic roof, both part of something wider than solitude. You drift now into the final image, the one that will stay with you as sleep folds over. The thought of 3I/ATLAS not as a fleeting guest, but as a permanent neighbour. After millions of years wandering between stars, this comet has curled itself into orbit around our sun, settling into a rhythm that may last for ages. Its path is long, slow, stretched into an ellipse that loops outward and then back again, like a breath drawn in and released. Every swing around the sun is another reminder. Sometimes visitors become residents. Historians still argue whether the solar system has captured other interstellar bodies before. Maybe some of the native comets we've catalogued for centuries are actually immigrants, their true origins forgotten. If so, Atlas is simply the first one we've caught in the act of moving in. And here's a quirky tidbit to keep close. In 2019, astronomers suggested that a handful of objects orbiting near Jupiter, strange asteroids with odd tilts, might actually be captured interstellar visitors from deep time. If true, our backyard has always been more cosmopolitan than we thought. You picture Atlas circling patiently, centuries blurring past, while humans change and grow beneath its watch. Ancient stargazers once feared comets as omens. Modern astronomers measure their spectra. Future civilizations may send probes, land on its surface, or even mine its frozen riches. Through it all, Atlas will remain, steady, quiet, a reminder that the universe sometimes gives us keepsakes instead of just passing notes. As your breathing slows to its gentlest rhythm, you allow yourself to imagine the comet as a lullaby in motion. Every icy fragment drifting off it is a star whisper, a reminder that the galaxy is not silent, that stars speak to each other through these small, stubborn travelers. You let go of the numbers, the debates, the excitement, and settle into the softness of knowing. An alien fragment has joined our solar system, and it will circle with us for ages. The sky feels wider, the night quieter, and you, like Atlas, are ready to stay, resting here, orbiting in calm. And now, as the comet drifts farther into the darkness of your imagination, the pace of this story slows, softens, lengthens. You no longer need diagrams or debates, just the gentle comfort of knowing that the universe is vast and generous, and sometimes it lets us keep a piece of itself. Imagine the night sky stretched wide above you, stars blurred into a haze, the faint curve of a comet's orbit drawn like a thread of silk. No rush, no urgency, just the endless sweep of time. Each breath you take is another orbit, slow and steady, carrying you deeper into rest. Let your thoughts fade like starlight swallowed by dawn. Let the comet drift quietly, far from noise and worry. In this softened space, there are no deadlines, no decisions, only the long, patient motion of worlds circling a star and you safe beneath their glow. The galaxy is not empty. It hums quietly, and tonight you are part of that hum, part of the slow, eternal rhythm. Close your eyes fully now and imagine yourself orbiting too, weightless, calm, forever carried by a gravity that asks nothing of you but rest. Sleep well.